Hello students, in this video we have a very common problem that is called Riemann problem in chapter motion in a plane, that is kinematics. So here I have an example for that. Suppose a rain is falling vertically with a speed of 35 meter per second and there is a woman who is riding bicycle with a speed of 12 meter per second in a certain direction. In our example we take the direction from east to west. Then we have to find the direction she should hold her umbrella. तो हमें ये बताना है कि वो किस डायरेक्शन में अपने अम्ब्रेला को होल्ड करेगी सो दैट शी कैन प्रोटेक्ट हर सेल्फ फ्रॉम दैट रेन. So first of all we have to be very clear about the directions. So this is east, this is west, north and south, vertical and downwards. So ये हमें बहुत clear होना चाहिए. Now let's make the diagram for the situation. So the rain is falling vertically with a speed of 35 meter per second. So rain is like this. Suppose this is the velocity vector of rain. So for rain this is VR vector and its value is 35 meter per second, right? This is the origin. Now that woman who is riding bicycle with a speed of 12 meter per second is going from east to west. So woman is going from east to west, means like this. Woman is going like this and her velocity is 12 meter per second. This is velocity of woman, that is 12 meter per second from east to west. So this is west and this is east. This is the velocity vector for woman. Now if the woman was stationary, अगर वो रुकी हुई होती, she hold her umbrella just above her head to protect herself from the rain, क्योंकि at that time the rain is falling vertical. Means if the woman is stationary, उसको rain vertical आती हुई appear होती and she just hold the umbrella directly opposite to that direction, that means over her head. So to protect herself, she has to hold the umbrella in a direction that is opposite to the direction of rain. So ultimately what is our target? We want to find the velocity of rain, the direction of velocity of rain, and if we know the direction of velocity of rain, then we can find the direction of umbrella because it is exactly opposite to that direction. Since woman is moving, she is not stationary, so the rain that is falling vertically with respect to ground, but with respect to that woman, that rain is not falling vertically. She doesn't feel that rain vertically over her. So basically we have to find the velocity vector of the rain with respect to the velocity of woman. So here we are talking about the concept of relative velocity. We want to find the relative velocity of rain with respect to woman, means VRW vector, and as per the relation the relative velocity is given as VR vector minus VW vector. So this is our task. We want to find the direction of this vector. Now let's see in the diagram. This is VR vector and this towards west is VW vector. If I make a vector just exactly opposite to that of same magnitude, means like this, then it is minus VW vector. So VR vector minus VW vector can be written as VR vector plus minus VW vector. So if I find the resultant of these two, vectors, I get VRW vector, and according to the law of vector addition, triangular law of vector addition, the vector starting from this point and ending here, this vector is VRW vector, whose value is VR vector minus VW vector. So we want to find the direction of this vector, and opposite to that direction, that woman has to hold her umbrella to protect herself from rain. Now rain is not from a single point, it is happening like this, means the rain is falling like this in the form of parallel lines. All these lines are parallel, and to give the direction of this vertical we need a reference line कि हम उसका डायरेक्शन और द एंगल किस लाइन के रेफरेंस में देना चाह रहे हैं. सो वी कंसीडर अवर वर्टिकल डायरेक्शन is the reference line. Then the direction of rain falling with respect to vertical, let it be theta. So same angle must be here. If these lines are parallel, then this angle is theta. So we have to find this angle theta so that we can get the angle by which that woman has to tilt her umbrella in the direction of her motion. This is the direction of her motion. So the woman has to tilt her umbrella. She has to hold her umbrella like this to protect herself from the rain. This should be the umbrella. So this is the direction theta from vertical in the direction of her motion. So now our target is to find this value theta. For this, if I make it as a parallelogram, if I take this as a parallelogram, then this value theta can be given by the formula tan theta is equal to, now for tan theta we know the value is perpendicular upon base. So for tan theta, this is the perpendicular and this side is equal to this, means it is VW upon, and this is base, so VW upon VR is actually the answer that we are finding. So let's substitute the values, and when we substitute the values we get tan theta is equal to velocity of woman with respect to ground is 12 and velocity of rain with respect to ground is 35. So we have to find theta is equal to tan inverse 12 upon 35 to get the exact direction in which that woman has to tilt her umbrella in the forward direction or in the direction of her motion to protect herself from the rain. So our answer is that woman has to hold her umbrella tilted at an angle theta, tilted at an angle theta in the direction of her motion. So this is our required answer. That's how we solve this Rain Man problem efficiently. Okay, so diagram is important. Diagram and the concept of relative velocity we have to know to solve this problem. If we also want to find its magnitude, then we can find the magnitude from this relation, that it is under root VR square plus minus VWK square. So we can also find its magnitude from this relation. That's how we can solve the Rain Man problem. So that's all for the video. For further videos, stay tuned and keep studying. Thank you.